So we already learned what is the log mean temperature difference in a previous slide, and this slide I will introduce what is the correction factors and how does the correction factors relate with the log mean temperature difference. Okay, so for the double pipe and 1 heat exchanger, we know that in order to calculate the heat transfer, we have to use this formula where the U which is the heat transfer coefficient, and A is the surface area. Remember, these two parameters, it depends on which surface areas that you refer to. If it's for the inside surface, so it is supposed to be UI and AI. If it's for the outside surface, it's supposed to be U naught and A naught. Okay, and with the log mean temperature is based on this formula. Okay, I already covered about this formula in the previous slide. Okay, but however, for the multiple heat exchanger, especially for the heat exchanger called shell and tube heat exchanger, whether it is 1 to 2 heat exchanger or 2 to 4 heat exchanger, there's a slightly difference because we have to use this formula. The parameters of U and A here remain the same, which is it is based on which surface area that we refer to. Okay, but the delta T here, we no longer use the delta T log mean, but we use the delta Tm. Okay, delta Tm here same as the for the outside surface. So what does it mean by the delta Tm, and how does it relate between the delta Tm and the delta T log mean? Okay, so this parameter is actually relate again with each other. Okay, which is the delta Tm is actually can be get by multiply the delta T log mean, same like what we use in here, and multiply with the Ft here. The Ft here is actually the correction factor. Okay, so the delta T log mean, as I said before, it is same as what we use here. Actually, this is the same thing. I just change it in the form of types of liquid here. Okay, so it is exactly the same. Okay, and lastly, about the Ft, which is the correction factor. How can we get this correction factor? Well, this correction factor, basically we get it from a table or appendix, where in order to refer to this chart, there's a chart that we have to use to get this Ft. Okay, so in order to get the value of Ft, we have to calculate first these two parameters, which is the Z and Y. Okay, so what is the Z and Y? Z and Y is determined by using this equation. Okay, so you should know what is your THI, TH out, TCI, and TC out. Then you'll be able to calculate what is the ZY. Okay, okay, this is the chart that we will use to calculate, to obtain the value of Ft that I mentioned in the previous slide just now. Okay, so we want to calculate the Ft value, and of course you need to know what is the Z and Y first. And I also mentioned in the previous slide, the Y and Z can be calculated from the formula here. Okay, so what is Y and Z? Y is refer to the value along this x-axis. Okay, and Z is actually the value which is on the line which is bent along here. This is all of the Z value. You have to be a bit careful here because the line is actually quite bending there. Okay, so for example, let's give a try. our y value, which is 0.4. Where is the 0.4 here? Yeah, there it is. Y is at 0.4. So the way to determine it, it will be easy if you just draw a line in vertical direction at your y value. For example, y is at 0.4 and your z is at 1.5. So you have to get where is the line which is referred to the z value at 1.5, which is at this line. Okay, here. So and then we identify where is the crossing point between these two lines. Okay, so this is our y line and this is our z line. So this line is actually intersect at this point. So by taking this intersect point and draw it along the y-axis, then this is the value of the FT that we are looking for, which is the FT in this case is at 0.78. Okay, I repeat again. It is just you have to know first what is your y first. Okay, so in this case is 0.4. So you draw a line in a vertical direction along your 0.4 value, okay, at vertical direction of the y line. Okay, and you find where is the value for z, which is the line which is a bit bending here, and in this case is 1.5. So the intersect between z line and y line, you take the intersect point there and extend it along the y-axis, where the value on the y-axis is your FT. Okay, so the chart which is used to determine the FT is available from your textbook, which is at figure 494. This one is refer to the heat exchanger 1 to 2 for the figure 4.9.4a. This is for 1 to 2 heat exchanger, and for this one, the B one is actually 2 to 4. So depends on the question whether it is referring to the heat exchanger 1 to 2 or 2 to 4. Then you have to use the correct diagram or the correct chart to get the FT value. Okay, based on the type of heat exchanger mentioned in the question. Well, this one is referred to the chart 495, and this chart is actually for heat exchanger, cross flow heat exchanger. Remember the cross flow type heat exchanger, we already discussed about this type of heat exchanger in part 1. Okay, so there are two types, whether it is shell fluid mix with other unmixed fluid or both fluid unmixed. Okay, so for the chart A is refer to the one which is one mixed and the other unmixed, and for B is refer to the chart which is used for the heat exchanger cross flow with the both fluid unmixed. Okay, again you have to make sure that you use the correct chart for according to the type of heat exchanger mentioned in the question.